Now let's take a look at this example where we have the reaction in solution. So we know that this reaction occurs in solution because most of the phases are either aqueous or liquid. Now, we have 750 milliliter of 0.806 molar of NaClO, and it is mixed with excess ammonia. So this one will be in excess, and when you encounter this word excess, that means that this is not the limiting reactant. So for sure, between the NaClO and NH3, NaClO will be the limiting reactant as the NH3 is present in excess amount. Now, we are being asked two questions. The first one is how many moles of hydrazine can be formed? And this is the hydrazine. And the second question is, if the final volume of the resulting solution is 1.25 liter, what will be the molarity of hydrazine? How do we solve this problem? You can pause this video for a bit if you want to try on your own first. As per usual, first thing is that we have to check whether the reaction is already balanced. Now, even though you find that some of the reactants or the products already have coefficient, still you have to check whether the reaction is already balanced. And in this case, it is already balanced, so we can proceed. Second step is to make any unit into mole. And in this case, we have molar and milliliter. That means we have molarity and we have volume. And we know that we can find mole by multiplying the molarity and the volume. Just remember that the volume needs to be in liter. So if you have 750 milliliter, then you have to convert this to liter, so you get 0.75 liter. And then you multiply this with the molarity, which is 0.806, and then you will get 0.605 mole of NaClO. Now, based on this, we can build our ICF table. We begin with 0.605 mole of NaClO, and we have the ammonia in excess, meaning that for sure ammonia will not be the limiting reactant as it will be remaining in the final state. The one that will be the limiting reactant is NaClO, and in the change state, we will have also 0.605 mole reacting. And now we have to find the mole for hydrazine, so we take it's here. And don't forget that we have to take the coefficient. In this case, it is 1. This is also 1. So 1 over 1 multiplied by the mole of the NaClO. So we will also have 0.605 mole of hydrazine. And this is the first answer to the first question. What about the second question? If the final volume of the resulting solution is 1.25 liter, what will be the molarity of hydrazine? Now we are asked to convert this into molarity. How do we convert mole to molarity? Molarity is equal with the mole of the hydrazine divided by the volume, which has to be in liter. So it's going to be 0.605 mole divided by the volume, which is 1.25 liter. And here we go, we have the answer, which is 0.484 molar of hydrazine. And this is the answer to the second question.